test is going to cover, it's kind of like the second part of 2.3 is where we left off. And it really came back into 2.5, but it got introduced in 2.3 is a lot of the stuff we're going to talk about. The first is the possible roots. So the possible roots are, remember, your plus and minus last over first. Okay, and in order for that to work, it's got to be in decreasing degree order. So I'm going to write it in decreasing degree order. I'm going to find the factors of the last term and then put it over the factors of the first term and list all my possible roots. That will be a question. This is one of the questions you're going to get on Thursday. Okay. Then it's going to say find the actual roots. So to do that, we test using synthetic until one works. Then you're either going to factor, use the even root property, which is like the square rooting of both sides, or use the quadratic formula to find the remaining roots. The question is going to ask you to list your remaining roots. That's so little, right? Let me see if I can get it. Don't need to stare at a bunch of black boxes. Okay, then it's going to ask you to list your factors, your roots, so you just list them with commas, and it's going to ask you to use linear factors, product of linear factors, okay? Product of linear factors. And this is when you do your x minus however many times you've got roots, okay? Remember, those can't be raised to a power, and they can't have a fraction in them. If it was minus 1/2, we would multiply everything by 2 so that we could get rid of that fraction. Also in this section was Descartes' rule. The question is also going to ask you for that, and by way of that, help you eliminate some of your possible roots. So remember Descartes, we count the sign change, well, the number of possible roots. Number of positive real roots equals the number of sign changes. And then the number of negative real roots. We plug in a negative x and then count. For both of them, we subtract by 2. So if I count 4 sign changes, then it's 4 or 2 or 0. If I count 3 sign changes, it's 3 or 1. 2 would be 2 or 0. 1 is just 1. So if I do Descartes' rule, and it's going to ask you to do Descartes before you get to the actual roots, if you did Descartes' rule and it said there's 1 positive, I definitely would test all my positives before I would do my negatives. If it said there's 2 or 0 positives, but there's 1 negative, now I would test my negatives before I test my positives, okay? So keep that in mind. Use that to help you narrow down your possible roots. That kind of question is on Thursday's part, but it kind of sinks in with 2.5, which is where I actually highlighted it, because 2.5 is where the i's come into play. So you will have imaginary roots there. No, you plug in a negative x, simplify it, and then count the sign changes again. Okay. So like if it's a negative x squared, it's going to go back to positive x. After you do all that, then you count the sign changes, and that's how many negatives. Okay, 2, 4 was your complex numbers or your i's. So we added, we subtracted, we multiplied, remembering to replace the I squareds with negative 1s. We divided, and this is what's on Thursday's part. You're gonna have to rationalize the denominator by multiplying by the complex conjugate. Remember the shortcut a squared plus b squared can be used on the denominators there. you're going to need your quadratic formula for this question on Thursday and then again on Tuesday. So that's x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And there can be i's in it. Remember, that's like in 2-4, the very last example was quadratic using with negative underneath, so then it results in an I. And then higher powers of I, you'll see this obviously in your test on the Tuesday part, but you'll also see this in standardized tests. They love questions like this. Like let's say it says I to the 36. Obviously you can do that by writing I times I times I times I 36 times, and then every group of 2 put a negative 1 and then multiply them out. That can be done. It just eats up a ton of time. So there is a trick. I'm going to show you what would happen first, and then I'll show you the trick to it. So every pair of i's is a negative 1, right? So if I rewrite I to the 36 as I squared to the 18th, because that's 36 divided by 2. And then I say, what's I squared? Negative 1. So I did negative 1 to the 18th. What happens when I have an even number of negatives? It becomes positive. This would be a 1. That's going to happen every time your initial exponent is even, and then when you half it, it's still even. Now, I'll show you, I'll put that in words, but just so you can see it happen first. What happens if this was 38? Now I would get I squared to the 19th, which would be negative 1 to the 19th. And what happens when I have an odd number of negatives? It's negative 1. So there's 4 different scenarios. This is if they're both even. It will either be, if it starts even, it's either going to be a positive 1 or a negative 1. Okay? If it starts odd, so let's say I had I to the 35, I'm going to separate out that extra I and repeat this process. So this would be I times I to the 34th. This becomes I to the 2nd raised to the 17th. There's my odd number of negative 1s, which means this is a negative I. If I made that 37 instead, actually let's make it 33, it would be I times I to the 32nd, I negative 1 to the 16th, which makes it positive I. So there are 4 possible outcomes with these. Positive 1, negative 1, positive I, negative I. Okay? I wanted you to see this before I tell you the shortcut so you believe me. Okay? But that, if you can't figure, if you don't remember what I'm about to show you, that's how you do it. Raise the 2 to the power, so divide it by 2, raise it to a power, replace the I squared with the negative 1, and then ask yourself, if it's an even power, it's going to go positive. If it's an odd, it's going to go negative. So the rule is this, okay? If your initial exponent is even or odd, those are the 2 cases. Okay, if it's even, and then after you divide by 2, it's even again, then it's a positive 1. If after you divide by 2, it's odd, it's a negative 1. If it starts odd, you divide by 2 and it's even, it's a positive I. If it starts odd and you divide by 2 and it's odd, it's a negative I. So evens will always result in a 1 or a negative 1. Odds will always result in an I or a negative I. But to get to that next sign, you've got to take your number and divide it by 2.
Can you just scroll up the 2.0?
Sure. You're welcome. Any questions on that? So again, if I give you something like 5 times I to the 38th, I don't want you to write out 38 i's and try to figure that out. I want you to use that shortcut. Okay, otherwise it's gonna eat up too much time. That would be on Tuesday stuff though. That's not Thursday. Okay, 2-5 was a lot of 2-3 repeated again, but this time with imaginary numbers. So this is the question that's gonna be on Thursdays. You're gonna do the possible roots, Descartes' rule, the actual roots, and then the linear factors. That part is on Thursdays. So first question, rationalizing the denominator. Second question, give me possibles, actuals, linear factors, Descartes' rule, and then the last two are the graphs. So remember, possibles and actuals are the same as the last thing, right? These are the same as up here. It's just that they're going to involve imaginary numbers. In 2-3, we didn't have imaginary numbers yet. Then we'll come on Tuesday's part, find the function if I give you roots. So, Jacob, you getting all this? Imagine I said that there was a positive 3 as a root, and then there was like a 2 plus 7i. And then I ask you for the function. You have to remember that complex numbers come in pairs. As soon as you see that 2 plus I, it means you're going to add on 2 plus 7i. You're going to add on 2 minus 7i. You're going to expand these out. And then multiply it out. Always start with the conjugates because the I will cancel out, make your life a lot easier after that. Yep.
The imaginary complex ones will always have like a conjugate to it, like 2 plus and 2 minus.
They always have a pair. Yeah. It could just say like 2 and 5i, and then you have to know it's negative 5i. It might not have a binomial, but you always add on the extra complex number. So that's on Tuesday's part. Questions so far?
So Tuesday's 2.5.
Thursday has part of 2.5,
Okay.
and Tuesday, yeah. When I open up the review, I'll have you like literally highlight the types of questions. Notability a little bit neater, and then I'll post it. Erica, anywhere specific?
2.5 is good.
Okay, you're welcome. Okay, so now open up the PDF review from Canvas, because we'll highlight. All right, then came our graphing, which is what we're going to spend a lot of today on, well, depending on how much time we've got left. Okay, so this, again, it makes up 44 points of your overall test. It's a lot, so you got to make sure you know what you're doing. The Thursday part's 58 points total. The next Tuesday's 42 points total. So we've done this for the last 4 days, okay, but we're going to continue. I'm going to write on that, Lauren. I don't know if you want to wait.
Oh, okay.
Yeah, it will get messier, but I'll add stuff. So my vertical asymptotes, we're going to set our denominator equal to 0. Sometimes we factor, sometimes we don't. Making sure it's an x equals. Our horizontal asymptotes have 3 cases. If the m is less than actually, let me put the n first. If the n is less than the m, then it is a y equals 0. If the n is equal to the m, then it's the leading coefficients. And if the m is greater than the m, then there's none. The slant asymptote occurs, separate this out. When the numerator n is 1 more than m. So the exponent in the top is 1 more than the exponent in the bottom. To find the slant, we divide top by the bottom and ignore the remainder. This will be in y equals mx plus b format. And there's my slant line. I probably should have spread that out a lot more, but you get the point. The zeros come from setting the numerator equal to 0. Okay, we can ignore the denominator because the denominator would get multiplied by 0 and completely cancel out. So it's just the numerator. Remember, the zeros are a list, okay? On the graph, they show up as x-intercepts, but when we write them on the line, it's a list. Pay attention to things like multiplicity because that will help you if it bounces or crosses through. The y-intercepts, we plug 0 in for x. And this is a coordinate point. Domain is the opposite of the vertical asymptotes. It's the denominator not equal to 0. And this would be an interval notation. The wholes occur if you can factor and simplify the original. Whatever you cross out is where your hole is.
So you have to be able to factor the top,
I mean, I guess technically you don't have to be able to factor it, but like something's going to get factored and cancel out because you usually don't get it already factored for you. But yeah, like the top could be x plus 1 and the bottom could be x squared minus 1 and the x plus 1s are going to cancel, but technically I didn't have to factor the top. It was already simplified. Does that make sense?
If it was just like x
X and then x squared minus 1 can't cancel, right?
No.
That wouldn't be able to cancel. But like x and 2x squared minus x, that you can take out the x in the bottom. And then that cancels, and that would be a hole. So if you cancel out a variable in the bottom, there's a hole there. So that second one would have a hole at 0. So like number 3 in the homework had a hole. And you're going to get examples in a minute, and they will have a hole.
Ms. Kussweiser, can you go back to the other page really quickly?
Sure. Everybody okay before I move? Yeah? Okay. I will try to write. You won't have something higher than a cubic, which is what those are. So this is Thursdays, right? 89 to 97. And then this is Thursdays, something like 105, 111, 113, where you have to use all the possibles, Descartes' rule, actuals, linear factors. And then the last page is the graphing. So there's a lot here. I don't need you to do all of it, okay? Especially after you do what we're about to do. This is just extra practice. So like this just says find domain. There's extra practice on domain. Then it says find the horizontal and vertical asymptotes. These don't even tell you to graph them yet, okay? Then you get to 2.7, and now it says vertical, horizontal, and slant, so it puts it together, and then holes. Then at the end, it says sketch the graph of the rational function by hand, and that's kind of where it's going to put it all together. So this is much more similar to what you're going to see on Thursday. It's got all those multiple parts, the stuff we just went over. The vertical asymptotes, the horizontal asymptotes, the slant asymptotes, holes, zeros, y-intercepts, and domain, okay?
So we should do all of them?
I would do as much as you need. I would actually probably start with the ones at the end. I don't even know if you need to do all of them. If you're good, if you're feeling good, if you've practiced, which we're going to do today, and then that's what I'm going to tell you to finish, one with a hole, one with vertical and horizontal, one with vertical and slant. Like if you do those, you should be okay. These are extra practice. And then if you look on the assignment for this, obviously it's not graded because all of these are odds, so all of them are on CalChat, but not your normal CalChat link that's on the home page. So I put the link directly to the CalChat for this in the assignment. it says use this CalChat link for these answers, okay? And it looks like this. Let's see if it's still open. Like when you go to the assignment, it looks like this, and it says check the answers with this because it's last year's book. There's the CalChat link. We're in chapter R for review. We're in chapter 2. We're in section R for review. And if I want to know question 111, I go to question 111 and I hit go. There's my zeros. There's my broken down linear functions, my x-intercept. So anything that you need in this part, there's my domain. It's not continuous, the horizontal asymptotes, the ones all the way at the end. I forget how far they go. There you go. You get your graphs too, okay? So all of that should be included. Like all of that is linked directly to the assignment. All right, we have about 20 minutes, and I would like to focus on the graphing in the 20 minutes. So you're going to go to Class Kick. I'm going to give you the code, and you're going to answer 4 graphing questions. That the solutions I will post on the video, okay, because you're probably not going to finish them before we leave, but this is the opportunity to ask questions as you go. Tonight, whatever you don't finish today, I want you to finish. You're not turning it in. This is solely for your review, okay, so that tomorrow you focus on the parts we highlighted and the graphs we're about to do, and you come to class tomorrow knowing what you know and what you don't know, and then you can ask for help tomorrow in class, okay?